Hello, this is about how to use your calculator to work out the modulus and argument of a complex number and how to get back from modulus and argument to the usual way of describing a complex number. Okay, so complex numbers are just points in a number plane with rules for adding and multiplying them. Here's a complex number and it's described in the usual way by the distance across, which is called the real part, and the distance up, which is called the imaginary part. So it's 1 unit across, root 3 units up, it's 1 plus root 3i. The other way of describing it is its distance from the origin and the direction from the origin. So it's that distance, which we call the modulus of z, those two lines, and it's this direction measured as an angle anti-clockwise from the positive real axis, which we call the argument of z. And the question is how to calculate them. You can calculate them by using Pythagoras in that triangle, and by using trigonometry to work out the argument of z, but you can do it all quicker and more reliably by using your calculator. You look for a particular key on your calculator. First, set your calculator to radians, then do shift of the plus key, and you see the calculator says pol, which means convert to polar, which is the name for this distance direction way of describing points. All we do now is put in the 1 and the root 3. So 1, comma, which is shift of right bracket, root 3. Then press equals, and it gives you the answer r equals root 2, theta equals 1.047, etc. That's good. We've got mod z equals 2. We have argument of z is 1.0472 to 4 decimal places. But maybe that's a fraction of pi, which would be a better way of describing it. And you can find that out by now pressing alpha and y and press equals. And what does it do? It tells you that your angle, your argument of z, is pi over 3, which is a neater way, a more exact way of writing it than as a decimal. You could have done the same with the modulus, if that came out as a decimal and you thought in fact it was an exact third. You would press alpha x equals, now here it just gives you 2, which is what you got before, but if it had been as a long decimal, maybe doing that alpha x equal would give you it as a third. Right, the final thing is how to get back from this description to your original description. And that's a key called rec, or rectangular, which is the normal way of describing points. So you do shift of rec, which is the minus key. You put in the modulus, the r, or the mod z, which is 2 in this case. You put in a comma, and then you put in pi divided by 3. So there you have it. You press equals and you get x equals 1, which is what we wanted, y equals 1.732. You might recognize that as the square root of 3. If you don't, press alpha again, press y, press equals, and it says root 3. If you've done alpha x equals, you get the exact form of the first number, which is 1, which you had already. The advantage of doing this over the method in the book is it's all in one calculation. Also, the book tells you to use inverse tan. And the trouble with doing that is if you do it for that point, you get exactly the same answer as you do for this point. And what you have to do then is draw a diagram and work out whether to add or subtract pi from the answer you get on your calculator or leave it exactly as it is. If you use Pol, you don't have to do any of that. You just take the answer from your calculator.